Recording in progress. Okay. So I will take a special lecture for this SVM because it is very deep and I want it to know you people thoroughly. So I'll take a separate lecture for SVM. How that hyperplane works, what is this maximization, what is the distance, everything I'll explain there. Okay, so let's move towards the next algorithm. Okay, so as previously saw, this SVM, this is also one line code, just SVM. Okay, svm.fit, and you will get the accuracy for your SVM. So just making all above code to markdown. Okay, so that I can run this code. Is my screen is visible?
Yes, ma'am.
Okay, so you can see that SVM giving you more accuracy than previous. One was 9.1, one was 9.3, another was 9, and this is 0.95, right? So SVM is giving you more accuracy. So the next one is K nearest neighbor. So what
Hello,
it is as, yes?
ma'am, can we use SVM to do multi-level classification?
Sorry?
I said we can use SVM for doing multi-level classification.
Yes, you can use SVM as a classification. Okay, guys, can you please ask me all the question at the end, because right now that recording is going on. So you can ask me all the questions at the end of the session. Okay, is it okay?
Yes.
Okay, fine. So next, moving toward the K nearest neighbor. It is as simple as that. The name is means showing. You can think of K nearest neighbors algorithm as representing each data point in the dimensional space, which is defined by the n features, and it's calculated the distance between one point to another, then assign the label or earn observed data based on the labels of nearest observed data points. KNN can also be used for building recommendation system. Okay, so I'll show you how that KNN looks like. So it is not possible for me to draw each and every diagram. So that's why I am using this diagram. Okay. So if you see here, this is your category A, this is your category B. Okay, you know the name of this category. Okay, but here are some random points. Okay, which you don't know that which point this the means to which category this point belongs. So here we use our K nearest neighbor. As the name suggests, what it will do, it will check the distance. Okay, if this is your first category like this, and if this is your second category, up to this, so it will check which data set is near. So if you can observe, this is much near to this point, so this will categorize, this will put it in the category A. And if you observe these 2 points, okay, which I have drawn lateral, so this will go in the category B because they are much more near to category B. So that is how K nearest neighbor works. So the next is yes, the code is this method is also similar. Just making it markdown so that it stop running. Here is also markdown. Okay, and if you run the KNN, okay, sorry, this code. So the accuracy is, no, this is for SVM, right? The accuracy is 0.95, same. Okay, so the next and the last one is naive Bayes, which is comes under the naive Bayes theorem, an approach to calculate conditional probability based on the prior knowledge. And the naive assumptions that each feature is independent to each other. Okay. The biggest advantage of the new base is that while most machine learning algorithms rely on large amount of training data, it performs relatively well even the training data size is small. Okay. So if you have means data set sorry. So if you have the number of data set, or that is the your input data is in small in size, you can go for the new base. Okay. It is most important, means one of the good feature of new base that it gives output or accuracy good on the like with the less number of data. Okay. Then the Gaussian new base is the type of new base classifier that follows to the normal distribution. Okay, so in the new base also it is very vast, where that Gaussian distribution, normal distribution, uh, this all concept comes under the new base. Okay, so we will also explain it one by one, but in the very short time I will show you the formula. Okay, for the probability, means how new base calculate this probability. Okay, so this is your formula for the new base. This is probability of A to B, probability of B to A into I hope you people are aware of this. If you belongs to that IT, or if only if electronics or statistic people have this formula, even they know the formula for entropy, and are you people aware of that formulas like entropy and all the things?
Yes, ma'am.
Okay, because statistic is one of the most important part belongs to data science. Linear algebra is also important. Probability is obviously, because without means it is also one of the where we see the probability of occurrence. Is it if the most probable thing will we can classify them, right? So this is okay. So as everyone knows, this is posterior likelihood. Okay, these are the just simple formula which we used during the college. Okay. So in here also we have a one line code for Gaussian. Okay, and yes, we use Gaussian new base. Okay, is the type of new base classifier that follows the normal distribution. For the normal distribution, we use this Gaussian curve. Which I hope you people are aware of that all the things. Now let me show you. Like this is your normal distribution. Okay. So this is all about the brief introduction of every classification algorithm. Okay. It is not possible to cover all in 1 hour. So we will see the most important, or like SVM algorithm or decision tree or random forest. See, SVM is giving us more accuracy, right? And random forest is also giving us more accuracy. Logistic regression is already done. So we will try to cover the SVM and decision tree as well. Okay. And the terms related to them in our upcoming lecture. Okay. So got this at least if you people are aware of these 6 algorithms, which belongs to classification. Okay. So that is enough for me for today.